Now let's talk about circuit elements in a little bit different way. Let's talk about realistic voltage and current sources and IV curves associated with common elements. Let's talk about open and short circuits and switches, particularly wiring three-way switches. An ideal voltage and current source has no resistance. The voltage source just produces voltage, the current source just produces current. But a more realistic, non-ideal voltage source and current source has resistance. A voltage source has a resistor in series, and a current source has resistance in parallel, called the shunt resistance. You know that most of your sources are realistic because they heat up when you use them. Your power drill, for example, gets hot when you use it very long, and that's because of its internal resistance. Here's a graph of the internal resistance of a battery. Batteries get hot when we use them too. Certainly my laptop battery does. So you can see that this battery, this is an Energizer 1.5 volt AA battery, as the temperature changes, so does its internal resistance. Its internal resistance is just going to be, oops, I want to go up, not down, is going to just be this series resistance that's right here with the battery. So let's take a look. Now, if you were at room temperature, the internal resistance of that battery would be about 0.15 ohms. And if you were in Antarctica, which is where I did some measurements, and let's say that you were about minus 10 degrees centigrade, then your resistance would be about 0.3 ohms. Let's see how that affects you. Let's suppose that you just wanted to hook up this battery with its internal resistance to a very small load. I'm going to use a 1 ohm load for this example. I would find the current that's in the circuit by taking the voltage and dividing by the sum of the two resistors. So in this case, if I had an ideal source, it would be 1.5 volts divided by my 1 ohm load, and so I would have 1.5 amps for the ideal battery. But now let's say that I'm at room temperature. In that case, my internal resistance is 0.15, so if I add that right in here to my 1 ohm, I'm going to have 1.3 amps at room temperature. It's a little less than I had for my ideal battery. Now let's go to my Antarctica battery, and that's where I have 0.3 ohms connected onto my 1 ohm load, and I'd have 1.15 amps when I really intended to have 1.5. So what did that do? This is why our batteries went dead so fast in the Antarctic cold. Now let's talk about IV curves. Here are the IV curves for the simple circuit that I just showed you. You have a battery connected onto a resistor, and what you would be plotting is voltage on the x-axis and current, or I, on the y-axis. The IV curve for a resistor is always a straight line. The resistor is a linear device. If I had a 1 kilo ohm resistor, for example, connected onto a 1 volt battery, I would have 1 milliamp of current. If I had a 2 kilo ohm resistor, I'd have half a milliohm of current. And if I had a really high resistance, let's say infinity, I would have no current at all. On the other hand, if I had a very tiny resistor, let's say 0 ohms, I would have no voltage, but I'd have a very large current. What does that mean? Having a resistor of 0 is a short circuit. That's where my current runs away with me. I have a huge current, and my voltage would be 0. An open circuit has a very high resistance of infinity, and in that case you have no current, but you have a very large voltage. The IV curves for an LED are nonlinear. The LED is a little light bulb that turns on when we put a voltage across it. We're going to be using it in our first or second lab. So you can see right here that there are different colors of LEDs, and that as the voltage increases for each one, see, I'm turning up the voltage, and the current becomes very high. This elbow right here, where the current goes from being almost 0 to becoming almost its final value, is called the forward turn-on voltage. And right here for the red one, you can see the forward turn-on voltage for a red LED is about 1 volt. The turn-on voltage for a white LED would be a little bit higher. Now let's go back to our idea of the open circuit and the short circuit. If I have an open circuit, my current is 0. My circuit may not work, but at least it's not going to run away with me. A short circuit, on the other hand, has a very small resistance, but an extremely high current. That's what can actually do you some damage. A fuse or a circuit breaker is what's intended to keep the current from running away with you. If the current was trying to go to infinity, but we had a 10 amp circuit breaker in line with that, the circuit breaker would trip when the current got to 10 amps, and it would shut the circuit off. A circuit breaker is a type of switch. There are several other types of switches. The most common that we use when we do our designs are single pole, single throw switches. That's just a switch that you just turn on, turn off, turn on, turn off. The other is a single pole double throw, where you turn on here or you turn on there, turn on here, turn on there. And there are many others as well. I've put a link on the website, and I thought it was pretty interesting for you to see all the different kinds of switches that you might be using throughout your career. One very interesting switch circuit is the three-way light switch. That's where you have a voltage source connected onto two single-pole double-throw switches. These are very common along stairways or hallways because you want to be able to turn the light on or off from the top of the stairs as well as from the bottom of the stairs. Now right here in this circuit, you'll notice that these two switches have to be connected by a double set of wires going between them, and then they're connected onto the lamp or the light bulb along the neutral line. We often choose to use the light bulb in the neutral line instead of the power line because in the event that someone was taking the light bulb out, and let's say that they accidentally got their finger or maybe a piece of maybe a tool across here, and somehow they managed to short themselves to a live line, to the ground, if we were connected to the neutral, nothing should happen, but if they were connected to a live line, it should. So most often, the lamp is put on the neutral line for safety. So, in conclusion today, we've talked about voltage and current sources, open and short circuits, and switches. I'd like you to take a minute to try the three-way switch in your Multisim simulation. It's a good chance to get to practice with Multisim, and it's fun to see how the three-way switch works. Now let's talk about where the picture was in the front. This is the Sunflowers and Thunderheads picture from Black Hawk Trail in Payson Canyon, Utah. See all these yellow sunflowers along here? It's absolutely amazing. This is normally the week of the 4th of July.